Welcome to MyProjectBazaar.com.
Now we discuss about the product for performance analysis of a low power high speed hybrid 1-bit full ladder circuit. Next we see the abstract for the product. Increased usage of a battery operant portable devices like a cellular phone, personal digital assistants and the notebook demand VLSI and ultra large scale integration designs with the improved power delay characteristics. Full ladder being one of the most fundamental building block of all the aforementioned circuit applications, remaining a key focus domain of our researchers over the years. Since static full ladder are generally more reliable, simpler with less power requirement, but the one chip area requirement is usually larger compared with its dynamic counterpart. Different logic style tends to favor one performance aspect at the expense of others. Standard static complementary metal oxide semiconductor, dynamic CMOS logic, complementary pass transistor logic and the transmission gate full ladder are the most important logic design style in the conventional domain. The other adder design used to more than the one logic style known the hybrid logic design style. For their implementation, these designs exploit the features of a different logic style to improve the overall performance of a full ladder design. In this paper, the hybrid 1-bit full ladder design employing both complementary metal oxide semiconductor logic and transmission gate logic is reported. The design was first implemented for 1-bit and then the extended for 32-bit also. The circuit was implemented using the Addons Visual tool. The performance parameters such as the power delay and the layout area were compared with the existing designs such as the adder and transmission function adders and hybrid pass logic and static CMOS output drive full adder and so on. For 1.8 voltage supply and 1.8 nanometer technology, however, the power consumption was found in the extremely low with moderately low delay resulting from the deliberate incorporate of very weak CMOS inverters coupled with strong transmission gates. These are the transmission gate based process to be applied in our hybrid CMOS based adder logic. We developed the 8-bit transmission gate based hybrid full adder architecture for the 8-bit addition process. This process mainly do in our layout based structure for using the Tanner LED software for our overall architecture process. These are the final abstract for our product. Next we see the flow diagram for the product. First we the input data bits to be applied in our overall layout based hybrid adder architecture. This hybrid adder architecture to consist the hybrid full adder CMOS circuit design. This CMOS circuit design mainly based on the transmission gate logic for the 1-bit full adder addition and addition summation and the carry selection process. This adder function to be converted in the layout based structure designs and to develop the hybrid full adder layout design process. This layout design process to be performed in the single bit hybrid adder addition process. Then to passing the 8-bit carry save adder circuit design for overall layout based structure. This layout based structure mainly do the Tanner LED software. Then we simulate and synthesize the our required 8-bit full adder order architecture process. Then to passing the simulation command and to generate the our adder output for required layout based structure design. Then the apply input voltage and to apply the data bits for our required simulation based commands. Then finally we see the sum and carry output for the final 8-bit carry save adder output design. This is the overall flow diagram for our overall process. This process mainly focused by the layout based addition architecture. The layout based addition architecture we use the metal and the polysilicon layers and metal contact and polysilicon contact and the internal wires for metal connections. All the things to be included for our layout architecture designs. Next we see the final output for the product. This is our the hybrid adder design for based on the transmission gate logic. This is the single bit layout architecture for our 1-bit full adder architecture and same like this architecture to be followed in the 8-bit carry save adder architecture. So we use this type of layers for the metals and polysilicons and the n substrate p select. These metals are used in our 1 bit full adder architecture. This is our the final design for our 8-bit carry save adder architecture. This is our the output window. This is the output window to be processed by the carry selection process based on our single 1-bit full adder architecture and passing the carry to the next bit addition process. This is our the same logic to be followed by the our 8-bit adder architecture. This is our the LEDit layout based edit design for our required hybrid adder architecture logic. This is our the final structure for our overall 8-bit carry save adder layout architecture diagram. Next, we apply the simulation based commands for our overall architecture process. This is the final output for our overall architecture design. This is the architecture based layout based architecture design output to be generate the analyzing command. So DC analyze and DC operating point and transient analyze, these are the applied commands to be inserted in our T-Spice window. Then to simulate the simulation graph, this is the output simulation graph for our overall architecture. This is our the transient results for our architecture. This is our the full adder output for our overall architecture process. Then to generate all the things to be separated in our architecture based process is the summation and input voltage process is the summation voltage process, the carry selection process. This is the final output for our overall architecture process. This is the simulation command DC analysis result. All the things to be processed by our layout based structure, and this output waveform to be seen in the WEdit waveform window for our overall architecture process. This is the final output for our 8-bit adder carry slave adder layout architecture results.